Hi, all my YouTube viewers. It's Crystal here. I'm just here because I wanted to do a code review. And instead of doing a code review on Python, which is what I've been doing code reviews on for the last 4 years, I'm going to do a code review on SQL. And the reason for that is because after 4 years, I decided it was time for me to expand my knowledge base, and SQL is one of the languages that you can use on the Kaggle website. And so I decided that since I could use it on the Kaggle website, I may as well learn SQL. And who knows, I may be able to get a job as a data scientist sometime, but I'm not really holding my breath. So what we're doing is we're using the data set on USA names. And what we're going to do is we're going to um, find all the names in Arkansas, where I was born, and we're also going to find my name. So that's what we're going to do in this simple SQL program. And as I learn more and more about SQL, I will make more complex programs. And the reason why is because with Kaggle, they only allow you to use so much data a month. And then once you've used your data allocation, then you have to wait until it resets to use it again. So I'll do as many SQL data sets as I possibly can, as long as I've got the data. And then basically what I'll do is I'll try to find small-ish data sets to use, because obviously the larger the data set, the more data you're going to use, and I'm going to use all of my data. So, so we've got USA name SQL. That's the name of this Jupyter notebook. I didn't put a problem statement because this is my first SQL file. But as I become more proficient in it, I will make problem statements. So the first thing we're going to do is we're going to import our libraries from google.cloud import BigQuery, and that's what we're using. We're using BigQuery datasets. We're going to import NumPy as NP, which creates the NumPy array and performs numeric computations. We're going to import pandas as PD, which creates data frames and does data processing. And I also included the visualization libraries, Matplotlib and Seaboard, but we haven't used those. But as I learn more and more about SQL, I will do data visualization as well. So this is the format for BigQuery to get your to get the data in Kaggle, because what we're doing is we've opened a Jupyter notebook on Kaggle, and we saved the Jupyter notebook into my Kaggle account. So client equals bigquery.client brackets dataset ref equals client dot dataset, and it's USA names, comma, project equals BigQuery public data, dataset equals client dot get dataset, dataset ref, tables equals list client list tables dataset, and then for table in tables print table dot table ID. And so we had two tables, a table of USA 1910 to 2013 and a table USA 1910 to current. So what we're going to do is we're going to construct a reference for the full table. Table ref equals dataset ref dot table USA 1910 to current. So that's what I want to use. Table equals client dot get table table ref, and then table schema. So this is your schema. This just tells you I think it's more like info in Python. So it tells you what the columns are and what they are string and how it's made. So that would be like, if you were using Python, it would be like the info function. say client.list rows table, comma, max results equals 5.2 data frame. So you're going to convert this to a data frame. You're only going to have 5 rows of data, and you're going to list those rows. So you've got your data frame index, then you've got your state, which is Alaska, gender is female, year is 1910, the names, and the number of names people named that year in Alaska. So now we do client list rows dot table selected field equals table dot schema 5 max results equals 5.2 data frame. So again, that's just showing you the table again, and then it said the schema is colon 5. That means it's the 5th column. If you had colon 4, then it would be the 4th column and you wouldn't be able to see number. So now what we're going to do is our query. So we're going to say arc names, and then it's going to be in triple quotations. Select name, year, gender, number from bigquery public data.usa names.usa 1910 current, and where is going to state equals Arkansas. So we're going to print everybody in Arkansas. Dry run config, bigquery.query job config, dry run equals true, dry run query job equals client query arc names, job config, dry run config, and it says this query will process a whole lot of bytes. I don't know how many. It's hundreds, thousands, millions, 195 million bytes. So that's a lot. That's a lot of bytes. And that's why I'm having to keep trying to find small data sets, as small as I can find, and not do very much work, because every query that you make is going to use data. And so far, I haven't used all of my data, but if I keep doing queries, that's going to happen. So arc names 1 equals client.query arc names.result.to data frame. And so it tells you all the names of everybody in Arkansas. So you can say Mary was a really popular name. It had 408. I'm really surprised about that. I thought that they would have more Marys, but that's what it says. So now we're going to set it up again. Client equals bigquery.client. Query job equals client.query arc names. Arc names 2 equals query job.to data frame. Arc names 2 dot name value counts head. So what it's doing is it's giving you value counts of all the names, and it's only giving you the first 5 names. So that's what the head is for. And that's what's interesting about SQL, is what I found out doing the studies, is that you can use SQL with Python, because a lot of the code is Python, but you're using SQL as well. So it says arc names 5,000. Select name, comma, count number as total num from BigQuery public data.usa names.usa 1910 current. Group by name, having count number greater than 5,000. Arc names 2 equals client.query arc names 5,000. Result equals 2 data frames. So this is every name that's over 5,000 in Arkansas. So Mary had 6699, Anna had 5664, and it goes down the list. Everybody that's over 5,000. So now what we want to do is we want to select all the names that are Tracy. So select name, year, gender, number from bigquery public data.usa names.usa 1910 to current, where name equals Tracy, arc names 3 equals client.query names Tracy, result equals 2 data frame arc names. And so now you can see in every year how many people named their daughter Tracy. What I find to be interesting is they didn't actually name anybody Tracy until 1953. So that's what I find to be very interesting indeed. So Tracy is not an old name. So I was born in 1961. So 12 people were named Tracy in 1961. Let me just see what it says. It says, so I don't know if this is just, it looks like it's just, because we could have put, it looks like it's ARC names 3. It looks like it's just in Arkansas that I did it. ARC names 5,000. So this was my first query, everybody in ARC. So it's ARC names. So it was ARC names, and it says ARC names 1, ARC names 2, and I don't know if that's everybody in Arkansas or if that's everybody total. What I need to do is I need to revise my query and specify the state. And then when you specify the state, then you'll know whether it's just Arkansas or it's everybody. So that's a good thing to do in my query, do another query. And so now what we want to do is we want to set it up again. And client equals bigquery.client, query job equals client.query, names Tracy 1 equals query job.to data frame, names Tracy 1, name value counts head. So this tells you how many people were named Tracy, and that's 4413. So it's not that many people were named Tracy. So that's very interesting. That is very, very, very interesting indeed, that Tracy's not that common a name. So what I do is I have to do some more work. I'm going to have to revamp my queries. And the reason why I'm going to have to revamp my queries is because on the Tracy, I need to determine whether it was just Arkansas or whether it was all the states. So that's something that I need to look into. So I'd like to thank you for watching my video. This is my first SQL data set that I've worked on, code review. So thank you again. If you like it, please like and subscribe. And I look forward to doing more SQL data sets, and I hope I get better in the process.